but it doesn't matter actually. Yeah.
Yeah, the first page, summary, flood.
Yeah. So last week I attended IGARSS conference. It is 100% virtual this time. If you guys don't know, the IGARSS is a very important meeting for IEEE Geoscience and Remote Sensing Societies, like annual. It's like AGU for Remote Sensing Society. And this year, 100% online, and they're very nice. They put all the information, all the slides, and the attendees have to, like presenters like us. We have to um, record a 5 minutes presentation and upload it online so everybody can watch it online and leave comments. And then we have a Zoom meeting to review, go over all of the presentations and have a Q&A. And around 7,000 submissions. Like they have a conference paper submitted, and they have accepted 1,800. So it's pretty low rate of acceptance, like 25%. And this conference covers, as you might see, all the topics from data analytics, data analysis methods, all the way, data management, and they have certain scientific things to be addressed. Um, they covered a lot of topics, and many of them are in my interest, such as artificial intelligence in remote sensing, new space, and some like modeling work. So, so I came to the conference basically with goals and take-home message to get the state of art works, which is like the pioneers or the leaders um, in this field and what they are doing recently, and to see the directions of academia society. And I want to learn some new data and the method, as well as the problem to be done, and what's the most interested um, problem to have to everybody cared about, and what they want to the way how they solve it. And good to remember certain like good conclusions and advances they have, and to know the leading players in these fields. And they say if we have ideas, what the other peoples have done, like that can be transferable to my own projects. Okay. I summarized basically the presentation attended into several topics, and now today I'm gonna
Are you
review.
there?
Hello.
Are you there?
Yes. Could you hear me?
Yeah,
Yeah, I want to
yeah.
here like I summarize several different topics of interest, and today I'm gonna go over the flood modeling and simulation, and they have a specific section. You can see it's Monday MO2R2. The topic is advanced flood monitoring and prediction for disaster risk reduction and resilience infrastructure, and they also have several other related presentations in other sections, and I may go over other topics in the coming weeks. So first, I found a good resource. Um, there is a website called the disasterchatter.org. It covers different types of natural disasters. They have a recent report. I encourage you guys to take a look. It's very good. Um, they have a Sudan flood, as I think I mentioned in my last presentation. They give a big, very good reviews. So it's a good resource. And also from other people, a guy, I think he's from NASA. In his presentation, he summarized all the natural disasters types and the uh, like how many like their occupation, like how many percentage for each type. And it's surprising to me to see that flooding and
Yeah.
storm takes almost like seven takes 71%. It's not like a majority of the natural disasters are related to storm and flooding, and I think it's very it's pretty much the main topic of the team, right? um, and also, I would like to share several good resources. There's an institute called Datmos. Dartmouth Flood Observatory. Maybe you guys know it. They have a good they have their own network of the gauges, and they can calculate the discharge for certain hot locate. You mean like hotspots, and they also serve as a hub to gather other resources like simulations, flood predictions, from like a global flood monitoring system that's from NASA, and another is from Europe, GLOFAS, Global Flood Awareness System. You can find all their resources in the DFO, the one Dartmouth Flood Observatory. And this is first some resources I would like to share. And then I find that in this conference, a lot of people are focusing on the SAR imagery, and how to use the SAR for flood monitoring. And they also have mentioned a little bit about the SWOT. I mean, that's very potential. I think the biggest sensor for the coming years for the hydrology. Um, and in the first picture on the top, you can see they have the SAR bands, because SAR imagery can be classified in different bands and have different kind of functionality. And you can see from the bullets, like the mostly widely used are Sentinel-1 SAR image. They are C band, pretty much in the middle. And a team from GPL, they are using UNet, like pretty much like deep learning infrastructure to flood to have the flood mapping in the region, like Houston, Texas, during the current Hurricane Harvey in 2007. That's their result. They are using UAV SAR, so it pretty much they put a SAR sensor on top of no on facilitated on the UAV, and they achieve such a good result. And this is you're using L band, so which means they have lower frequency, but they have a high ability to penetrate the objects. So it's and for I think so, right? ALOS, ALOS 2. That's from Japan. It's L band. That's all the sensors mentioned in the conference. And one called TerraSAR is X band. They have a high frequency, which means they have a high resolution, but pretty much low ability to penetrate the object. This is from Germany, like from ESA, and the radar SAT2 and the SMAP. I mean, everybody knows SMAP here. And then lastly, a team, I think they are pretty much a contractor of the SWOT. They give a good review of the SWOT's potential to estimate hydrology process globally in the ungauged basins. And they said a SWOT pretty much gonna launch in 2022, and they will measure all the rivers that are wider than 100 meters. So it's very inspiring. And then so now I can summarize certain presentations. They are using conventional approaches, so I don't give details. They are from India, Estonia, Japan, and France. Basically, the idea is to use a SAR image, and they use an empirical method to define the threshold value to classify the flood and the non-flood regions. So I don't give it good details here because it's very easy. And then a lot of researchers, they are switching to automatic flood mapping, inundation, and SAR optical data fusion. Here I list several researchers. One is from North Carolina A.T. State University. They are using UAV imagery, and you might know certain the method FCN is a fully connected neural network. It's a neural network method. They use a random forest, SVM, NDWI for the flood mapping. And another team from DLR, which is the Germany space agency, the guy called Martinez. I realized he has a lot of publications in the flood mapping. So I highlight his name. So his idea is to use a multi-sensor Earth observation data listed here, Sentinel-1, 2, Landsat 8, and TerraSAR-X, to estimate the extent of the flood, and they also estimate the duration of the flood. And they give a quality index for the duration. And here is the image. They did a project in a country in Africa. I think the Mozambique. Mozambique, yeah. Um, so and they have the I can give more details, but now for the time wise, they have the flood before the flood wedding, during the flood mapping, and they give a quality layer to show the affected areas and the duration of the flood for each region. And another guy from Luxembourg called Chini. Um, he's also another big guy because he also published a lot of related papers. I think they are the contractor from ESA eDraft project. It is a project Europe ESA. They plan to monitor the flood. They give us in this presentation. He gave a case study of 2019 monsoon season for three South Asia countries. That is their result. They have here he simply use a Sentinel-1 flood frequency map to show the flood frequency in this country. And then another group from Shanghai Ocean University, a group of Chinese guys, they are inherited. They proclaim they have a new network using the neural network to do the inundation flood mapping for the coastal area. And here you can see two pictures. The first picture, you can see their design of the neural network, and I believe it is a variant of a UNet. And on the table down there, they include the channels. Pretty much, it is the features of the SAR image in different, VV, which means the different types of backscattering, bipolar, and they also include certain like statistics to make more variables can be used to feed into the network. And the image on your right, you can see they are using in reconstruction. It's a very common application in the deep learning. They trying to train the network to perfectly reconstruct the flood area. Okay, so you can cluster the different types of land types and for segmentation. That's a team from Shanghai. And another guy from Peking University, also from China, they pretty much inherited certain tools of data fusion, and they promote idea called weighted evidential fusion. It is, I think, they published a paper in JSTAR last year, and they use a method. The method was used for other applications. Now they inherited this method for the flood mapping, and by this way, I also learned something like the data fusion, certain methods, PCR6 rule. That's a rule to solve the conflicting problem when you do data fusion. If you find the optical image and the SAR image have conflicts for certain objects, how do you solve the conflicting problems? And they have a good result, as they show in the table, like how could they inherit their fusion method to achieve better accuracy for the flood mapping. And this is very interesting. I'm trying to contact this guy and see if I can learn their further to have further cooperations, because this is very interesting. And another guy from Wuhan University, from China, they are focusing on the flood coverage, like to automatic extraction of the flood coverage on dynamic surface. Um, Here they are focusing on the thresholding because, as I mentioned, when you are using the SAR image target flood area, you have to define the threshold value to classify the flood and non-flood region. This threshold value is different from region to region, and here she wants to achieve automatic thresholding. And similarly, a team from NASA USRA, a lady called Jo, she's using a more apparent method using Bayesian joint probability. Firstly, they have also to automatic target the threshold value. Here she's using the Sentinel-1 SAR image uh, for the thresholding. No, for the image for classification, and he used a Planet optical image. As you might know, Planet is a very high resolution commercial image. He used it like a truth like a value to train the model and validate. If you're familiar with the probability, pretty much the first they want to mask the urban area and non-urban area. So it is if it is a non-urban area, they just use simply the 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 probability equation on your left, which are the px and the py, margin probability of flood observed from the Planet and Sentinel-1 data. But concerning the urban areas, because urban area has a certain issues, something like a double bouncing or multiple bouncing of the SAR image, you cannot simply use the same equation. You have to put a weight on the imageries to achieve better accuracy. That's why for the urban area, the probability become pxwp and pxpyws. They are weighted probability. So the weighted value are from 0 to 1. They're using the Planet optical image to define the weight, and they include the weight for the SAR image to classify the flooding area. And you can tell from, they give a good example here. Before they using the probability, joint probability, they only use a Planet to pretty much, here they have defined the thresholding with 0.48. And they have certain errors on your right down here. You can see the false positive by the man-made structures, because the threshold they select is not good enough to discriminate the man-made structures. And when they're using the joint probability, they draw a new histogram, and they define another good thresholding, pretty much like down the optimal value to discern the flood area. And you can even use this to incorporate it with DEM value to check the flood water depths. Okay, so this is automatic flood mapping. And then other people, they are trying to using other parameter of the SAR image, because now we only talk about the back scattering, but the SAR image can also be used with their coherence between different polarizations. Also, same guy, Cheney from Luxembourg, he's trying to introduce the core and the cross polarizations in coherence to map flooded area in the urban area. So he introduced is double bouncing and multiple bounces and its impact for the mapping. And he gave a work. This is the framework of how they achieve the flood mapping. Pretty much they separate the urban area and the bare soil flood area, and they introduce different indexes, then put them together to define the final flood map. And I put the link here. So it has way more detailed introduction of their method. And there is a result. And for the first row, it apply using a digital globe, very high resolution to define the overall flood area in the figure C. You can see the dark, the navy color is urban flood map, and the light blue is the bare soil flood map. And then for the second row, for DEF, that's separately they separately highlight the flooded area by different polarization. You can see from D it is vertical and vertical, and E is a vertical and horizontal. And in the figure F, they put these two as a coherence together, and they generate the overall flood map. You can compare figure C and figure F. You can tell that if they introduce the coherence method, the accuracy of the flooded targeting is tremendously increased compared to figure C. I mean, they are having a big they match pretty well. So it shows, okay, the coherence strategy is working pretty well. And then another group from JAXA, that's from Japan, and they promote us to reconsider the goal of the flood mapping, because you can see in the first figure, for the users, decision makers, they don't really care about these colorful pixel values, pixel maps. What they care is just a simple polygon, easy to understand GIS friendly map. Just show them where gonna getting flooded. So they also inherited a probability using Bayesian theorem to target the flooded area, and also because they make the entire procedure simpler, it reduces time. So it is good for decision maker to make timely decisions. And also, and lastly, I would like to talk about some people also talk about the soil moisture, such to related to flood mapping. A group from a university of Montana, they're talking about the satellite flood assessment, the forecast from using the SMAP and the Landsat, and as well as the GFS and area satellites to talk about the soil moisture and the flood mapping. Another guy from Italy, he talked about antecedent wetness. I think it is very important for the flood simulation. The conditions, right? The wetness before the flood, and how it related to the European floods. And you can see from the figure, it shows a previous study of the pretty much a linear regression between the water discharge. The runoff coefficient, which is S, whereas the pre-storm soil moisture, API5, which is the precipitation, and the soil moisture. Okay, so sorry. The first one is the river discharge. Second is precipitation. The third is soil moisture. And you can see the soil moisture achieve a beta R squares, which means the runoff are, of course, they are all related to the mentioned three parameters, but they are more related to the soil moisture before the model. So he continued with this study using Pearson correlation and mutation information to target the entire Europe continent for these three parameters. And you can see from the map, the first one is a pre-storm soil moisture, and it had achieved a better correlation. I mean, Spearman correlation in the in the Europe area, especially in Germany, France, Germany, and in the Western Europe, you can see the red dot. No, the yellow dots. They are achieving better than runoff. No, they achieving better correlation than river discharge and precipitation. And also the compute the mutation information. It is to describe the dependence between two random variables, because it is if you simply using especially a Pearson correlation, because Pearson correlation requires you to have a linear relationship coefficient. But here, using this index, I just learned this index is very useful for review the relationship between non-linear non-Gaussian variables. You can see for certain red dots, which show the precipitation achieved better consistency, which means this area actually they're all mountain areas. But for the majority of the area, for the navy dots, which means the soil moisture are the primary, the key indicator to show the flood mapping, or the notes to show the strong correlation with the runoff. And okay, and I was also worth mentioning certain people. This is from China Academy of Science. From China, they are doing hydrological modeling with using two different models. One is SWOT, one is a WASC model, and they estimate the accuracy of runoff simulation. They find the merged data are better than other data, and for the GLDS, it achieved the lowest accuracy. And also certain teams, they are like usually they're the big institute. They introduce the system design efforts. The first one is DFO, as I mentioned. The second one is from University of Connecticut. They want to build a system to talk about the storm power outage prediction using the NWP model and the remote sensing data to predict outage of the storms. And lastly, a team from Japan government, they promote the ICON infrastructure framework, also talk about implying SAR image and UAV SAR image for their own flood mapping projects. And also, lastly, I find several journals, mostly mentioned their remote sensing and IEEE transactions, remote sensing of environment, and also this conference, and the JSTAR and IRSPRS. They are all mostly popular journal that this people would like to publish. Also, I leave the link here. I think I'm gonna also share the link in the chat so you guys um, can see the presentation I installed in my Google Drive and their papers.